Hello, in this video we're going to derive the general solution for finding the marginal rate of technical substitution from a Cobb-Douglas production function. Here is our Cobb-Douglas production function, where a, alpha, and beta are all greater than 0. So let's solve for the marginal rate of technical substitution. First thing we do is get the marginal product of labor, take the partial derivative of the production function with respect to labor, and here's what we get. The exponent on the labor term comes down in front, so alpha comes down in front, and then we subtract 1 from that exponent on the L term. We have this result. Next, we get the marginal product of capital, taking the partial derivative of the production function with respect to K. The exponent on the K term comes down in front, and then we subtract 1 from that exponent on the K term, so now it's beta minus 1. The marginal rate of technical substitution is the marginal product of labor divided by the marginal product of capital. So now we'll make our substitutions into this formula. So in the numerator here, I'm just rewriting the marginal product of labor. In the denominator, we have the marginal product of capital. And now we're going to simplify. First thing you'll notice here is we have an A in the numerator and an A in the denominator, so those A's cancel. So after canceling the A's, we get this result. Next step here is I'm going to take this L raised to the alpha minus 1, and I'm going to move that into the denominator. When we move that term into the denominator, we have to reverse the signs on the exponents. So it's now going to be minus alpha plus 1. Next thing we can do, we can add the exponents on the L terms. So we got alpha minus alpha, that'll cancel, and we're just left with L then here. So simplifying. Okay, moving on. Just rewriting that last equation. And now I'm going to take this K term in the denominator and move that up into the numerator. So here again we have to flip the signs on the exponents, the terms in the exponents. So we got minus beta plus 1 instead of beta minus 1. And now we're going to just add up the exponents on the K terms here. The betas will cancel, and we're just going to be left with K in the numerator. So that is a general solution for the marginal rate of technical substitution for a Cobb-Douglas production function. Let's do a few numerical examples. Example 1, here we have this Cobb-Douglas production function. So alpha is 2, beta is 5. Plugging that into our formula, that would be the marginal rate of technical substitution. In example 2, alpha is 0.5 and beta is 0.5. Plugging that into our formula over here, the 0.5's cancel, and we're just left with K divided by L. Example 3, alpha is 0.8, beta is 0.2. 0.8 divided by 0.2, we get 4K divided by L. We don't have to do anything with the 3. As we saw before, 3 represents A, and the A's cancel once we derive this general solution. And our final example, example 4, alpha is 3/4, beta is 1/2. So to simplify this, I'll just multiply the denominator and numerator through by 2. So doing that, we're going to get 3/2, and 3/2 just simplifies to 1.5. So 1.5K divided by L is the marginal rate of technical substitution. Okay, that's it.